Welcome to E-Padasala PG program for computer science students. In this module, we will be looking at interfacing the external devices using embedded C code. In this lecture, we will be covering the interfacing of external devices with 8051, and we will be discussing about interfacing of external memory with 8051, and at the end we will be demoing the embedded C codes for interfacing 8051 with the different external devices. So, first we will be looking at the LCD display, that means the liquid crystal display. This is an external device which is attached with 8051, so that which enables to send some of the informations to the outside world through the display. Remember that 8051 is a microcontroller which is not having any of the display devices. If we wanted to communicate to the outside world through a display, then we have to connect this kind of LCD kind of external devices to the 8051 controller. For that particular reason, this device has been connected, and we need to know what are all the things we have to invoke to communicate with LCD devices. So, the LCD device is very helpful to provide the user interface as well as for debugging purpose also. So, the liquid crystal display is a flat panel display which uses the light modulating properties of liquid crystals. So, the LCD modules can present the textual information to the user. So, when you are looking at the interfacing of LCD with microcontroller, this is actually with respect to the hardware part, where we will be connecting, we have 7 pins, 8 pins are there for communication. Here we will be connecting 4 pins for communication, data communication purpose, and this E enable pin, and these pins are connected, these are all control pins which is connected over here, and the ground VCC and the contrast pin is also there which is connected to VCC, ground, and all these things. So, now this 4-bit interface, 7 lines needed to create a 4-bit interface which enables to display 2 line and 16 character with LCD display. So, the pin descriptions of LCD. So, when you are looking at this LCD, we have 14 pins. In this, the pin 1 is VSS and pin 2 is VDD and this pin 3 is VO. That means, these two are supporting the VCC and the ground, and this is for contrast adjustment. So, RS is nothing but register select signal. That means, the LCD should be selected by sending the signal at RS, and RW, which signal, this signal is used for making whether you wanted to read it or write it with respect to LCD, and this E is for operation. You wanted to enable the LCD by sending a high low pulse at E, and this DB0 to DB3 and DB4 to DB7 are the 4 pins which is used for connecting up 8051 controller with this LCD. So, it is a bidirectional pins where you can send as well as receive the data. So, these are the commands we should know when you are looking, when you wanted to operate with your LCD. So, if I am saying that 1, then hex code, these are all hex codes, we have to send the code as hex code, so that the LCD understands what we are trying to do it. So, if I am sending a 1 which says that clear display screen, if I am sending a 2 which identifies that return to home. The same way, if I am sending a 6, then increment cursor, and if I wanted to send something like 10, then it sends shift cursor position to left. If I wanted to send a data 14, then shift cursor position to right. So, that way if it is if I am setting a data of 38, then it says that 2 lines and 5x7 matrix display has to be initialized. So, if I am sending a command to LCD, this values has to be sent, so that the LCD understands this informations. This is a circuit diagram, hardware circuit diagram to interface the LCD with 8051. So, you just see that this is your LCD, this is your 8051, where with the port 0 we have connected this 4 data pins as well as your enable pin as well as your read, write and all those pins are also connected to some of the pins of your P0. So, this is your ground pin and you will be connecting it to VCC also. So, anyway the contrast is adjusted through this particular one. So, when you are looking up an 8051 and LCD together, the P0 is used for connecting the data pins to communicate between these two persons. So, now this is a code which says that how to communicate an LCD with an LCD to display certain things. So, this example code says that we are sending a letter MDE to LCD using the busy flag method. That means, we will be looking at the LCD whether it is busy or not by looking at a pin 1. We will be looking at the pins, so that the busy message is identified and we will be waiting not sending the data to LCD. If it is not busy, then we will be sending these data to display at LCD. So, this has been demonstrated with this embedded C code. So, here port 1 is connected to LCD pins D0 to D7 and P 2.0. Anyway, this each and every code when you are writing up, we need to identify that where the LCD data pins are connected. So, here in this code we are writing a code for, we have connected the LCD data pin at port 1 and the port 2.0 is read select, register select and P 2.1 is read bar write, P 2.2 is E pin. And P 1.7, that means port 1 7th pin is for checking up the busy flag. If this is 1, then it is busy. If it is 0, then it is not busy. So, that way we will be using it. So, now I am just making it SFR IData 0x90. That means this is 90 is the address to address port 1. So, now if I am accessing P1 which says that the L data, if I am putting it L data, then this will be sent to this particular address which in turn sent to port 1 and S bit RSP 2.0, 2.1 and 2.2, 1.7 is made it as a bits with S bit. So, that RS, RW, EN and BC is assigned with these bits. So, all the things which we have been taken from the hardware configuration that has been written with your C code. So, now void main where we will be making up LCD CMD 0x38. So, 2 line 5 cross 7 matrix. So, if I am calling LCD CMD and sending with the data of 0x38 which indicates that we are informing LCD 2 lines 5 into 7 matrix. Then again I am sending LCD CMD 0E. So, 0E communicates to the LCD for showing that the cursor is blinking, display on cursor blinking, and we are making 01 sending through LCD CMD clear the display screen. 0x is sent through this function LCD CMD to increment the cursor, and we wanted to place the cursor on line 1 position 6 by sending 86 LCD CMD of 86. Then after that in the first line 6th position we wanted to say M, so that we will be making up LCD data. This is a function called to display M. Then LCD data D which displays the second position, the data D. LCD data E, it displays E in the next position. So, from first line 6th position onwards 1 position increments and each and every time this gets displayed over there. So, now we will see that how this works, LCD CMD and LCD data, how this will work through this particular functions. So, LCD CMD unsigned character value, I am just passing the value through this value. LCD CMD first I will check that LCD ready or not, then IData value. So, the value whatever be the thing which I am sending it is passed to IData, that means P1 port 1, the data port is connected to P1. So, the value is assigned with the port 1, RS is equal to 0, we make the read select as 0, that means remember that it is negative logic system. So, that if RS is equal to 0, this LCD chip is selected. Now, RW equal to 0 which makes that this is for writing. Enable is equal to 1 which is first enable is equal to 1, after that I called a delay, after that I called a 0. So, 1 after that a delay, then there is a 0, that means high to low pulse is sent to enable the E. It is not looking at either 1 or 0. We need to send one high and one low pulse, so that we wanted to enable the LCD. So, LCD data is nothing but LCD ready function is checked. After that, LCD data value is sent, RS is equal to that means the value is passed towards the data pin port 1, then RS is equal to 1. This is for data. Remember that previously it is a command, so we made it RS is equal to 0. Now, it is a data, so we are making it RS is equal to 1. Now, RW equal to 0 for write, enable is 1 first, then there is a delay, again it is a 0. So, high to low pulse to enable and return. So, these two are the two routines we called, subroutines we called to send the data as well as to send the comments. Now, this is for making up whether it is busy or not. That particular function, that particular thing subroutine is LCD ready, where busy is equal to 1. That means first we are making that the busy is nothing but port P 1.7. We made this is equal to 1 to make this is an input pin. Then RS is equal to 0, R1 this is for reading. So, because of that RW is equal to 1. Previously we have written, so we are writing it, so it is 0. Now, we wanted to read it. So, because of that RW is equal to 1. Now, while busy is equal to 1, that means indefinitely I will be waiting over here as long as I am getting a busy is equal to 1. If busy is not equal to 1, that means it is 0, then I am coming down, I am enabling it by making it En is equal to 0. So, this is 0, after that this is 1, which makes that the enable, I mean it has been, the busy flag is down, so that now the system is not busy, so that I will do all these process. So, this code says that how to interact with the things. But anyway, the delay, each and every command when I am sending it, I need to insert a delay in between, because the LCD needs some time to recognize the commands. So, for that this is actually unsigned integer ij, for I is ranging from 0 to I time, what will be the time I wanted to, how many milliseconds I wanted to delay, that I will be making over there, and 0 to 1275. So, each and every one count, the for loop is rotated for 1275, so that how much is the time I wanted to make it delay, I will be running this nested loop, so that the delay time has been executed. So, this particular code demonstrates how to write a data to LCD through an embedded C code with 8051. So, the next external device is your keyboard. So, the output device is LCD device, the input device is your keyboard. So, one of the input device of keyboard interfacing is given over here. There, just look at, this is a 4x4 keyboard, we have taken it, where the data from 0 to F, that means the hexadecimal characters has been assigned to the 16 keys. So, if I am pressing a key over there, then it is a 0. If I am pressing a key over there, then it is a D key is pressed. That is what we are trying to say. Here, the keyboards are arranged in a matrix of rows and columns, and controller access this both row and column through the ports. So, this has been connected to port 1, so that this rows are connected to port 1 and the column is connected to port 2, so that I can access the rows and columns through port 1 and port 2. If this is the structure, we need to know how we will be finding out which is the key pressed. So, to find out the key press, the controller grounds all the rows by sending 0 on the port. So, then it reads the column. So, if the data from the column D3 to D0 is 1111, then no key is pressed. If any one of the column is 0, then it indicates that some key is pressed. So, for example, if I am getting 1110, then I will say that key pressed in column 0. That means this is 0, so that everything grounds over there through that particular thing. So, only I am getting a 0 over there. If I am pressing the second key, then I am getting 1101, key pressed in column 1. That means pressed key grounds, so that the whole thing goes over there. So, we will not get a data over there. So, it is 0. So, 101 says column 2 and 011 is column 3. So, by reading these values, we will be in a position to understand which column is pressed. So, when you are looking at which is the key has to be pressed. So, we need to know which row also, then only we can intersection of the row and column together to find out which is the key is pressed can be identified. So, begin with row 0, the microcontroller grounds it and providing the low to row D0 only. So, it reads the columns. If the data read is all or 1, no key is pressed. If it grounds the next row, reads the column and checks for any 0. If this process continues until the row is identified. If any one of the 1 is 0, then I will identify that particular row is getting pressed. So, after identification of the row in which the key has been pressed, we will be finding out what is the column pressed, so that we will be in a position to understand which row and which column we have identified. The crossing of these two things like a matrix, we will be in a position to identify what key is pressed. So, this is an example. If D3 to D0 1101 for row and D3 to D0 1011 for the column, then row 1 and column 3 is pressed. So, which indicates that key 6 is pressed. So, if it is, this is a second example, if I am getting on the row 1011 and 011 for column, then key B is pressed. So, this is the way we will be identifying it. So, now we will see that how we will be connecting in the hardware the keyboard with 8051. So, just see that this is the keyboard where 4x4 and the ports, these pins are connected to this LCD, I mean the keyboard pins are connected to 8051's pin, and this output pins are also connected to 8051. To see what key is pressed simultaneously, the data sent to an LCD, so that we will be finding out what key is pressed as recognized by 8051 and that particular value is sent to LCD to identify which key is pressed. So, this hardware setup is used for identifying which key is pressed and to display that key also. So, this is a code which demonstrates how we will be reading a particular particular key, so that we will identify which key is pressed. The same way we will be looking at a bigger keyboard in a matrix form. So, this is a simple keyboard which has 4x4 keys only, that means 16 keys only. So, now you just see that we made it include reg51.h, define column P2 and COL is P2 and hash defined row is P2. So, I will call column as P2 port and row as P1, I mean P1 row, P1 port as row and P2 as column. So, now first I will be looking at, so these are the two routines we will be using for delay as well as sending a data SERTX, and this is for keypad. I am just assigning what way the DB is there. So, character keypad 4x4 which has 0, 1, 2, 3 up to F. So, 4x4, if it is 4, 4 it is F, 0, 0 which is 1, 1 which is equal to 0. So, that way I have to identify the data. So, now you just see that this is the main code where tmod 0x20 which makes, we wanted to set the time, I mean you just see that we wanted to first read the keypad, send the result to the serial port. In this P0 to P3 is connected to rows, P20 to P2.3 is connected to columns, and the serial port for displaying LCD data in the serial communication with 9600 baud rate and 8-bit and 1 stop bit. So, these are the setups we are maintaining it. Because of that, first we have to make the serial communication. So, because of that we will be making tmod 0x20, th1 is -3 and scon is 50 and tr1 is 1. So, now the serial communication is established. After that, first we need to find out that is there any key is pressed or not. So, first column is equal to made it as 0xff. We have assigned this particular value, that means we find that we declare that column is a P2 port is a input port. Then while 1, it is a repeat forever loop where rows equal to 0, that means I am grounding the row. So, 0x00 ground all rows, column location COL LOC is column location which is equal to COL, read the column, and call location is equal to ANDed with 0f. That means the upper nibble is masked by putting ANDed with 0, only the lower nibble, that means the 4 things we wanted to see it, that means we will be taking only P1 to P3 as well as P2 to P2.0 to 2.3. So, this 4 lower nibbles has to be taken. Because of that, I have ANDed with 0F, so that I will be taking only the last LSB 4 bits. So, now I have ANDed it and I found that I will be looking at is there any keys are pressed. If something is already pressed, we wanted to release it. So, because of that, we have to wait till I have to get 0F. That means all the keys has to be released. So, once the keys are completely released and everything is 111, now we are going ahead with the code to test that which key is pressed. So, first we have to say MS delay 20, that means I am giving a delay. After that, I am reading the column position and it has been placed in column location, and if we will be looking at is there any column is pressed or not. So, I am ANDing with 0F. So, this has been we will be waiting in this particular loop till it will be 111. When it is not equal to 111, that means F is nothing but 111. If it is not equal to F, then it comes out. That means if the some key is pressed, so that only it is getting a value of 0 over there, so that it is not equal to F, it comes down. So, now I am making a 20 delay, MS delay 20. Now, millisecond delay, 20 millisecond delay is called. After that, I have read the column which is placed in a column location. It has been ANDed with 0F, so that the 4 bits has been identified. Now, I will be looking up the call location, I mean the column located value is equal to 0F or not. I will be waiting for a key press. So, if something is pressed, this will be not equal, then it comes down. So, now I have identified, now I need to identify some key is pressed, what is that particular key. Because of that, first I will make the rows equal to 0F FE. So, I am making it the 0th row is grounded, so that only it is FE. Then column is red and it has been assigned over there, which is ANDed with the 0F. Now, I will be looking at if it is not equal to 0F or not. If it is not equal to 0F, that means some of the key is pressed. If it is pressed, that means the row is 0. So, I made it row becomes FE. So, if I am getting 111, that means F, then nothing is pressed. If I am not getting 111, that means not F, then any one of the bit is equal to 0. So, which means that the row 0th row is pressed, any one of the column in the 0th row is pressed. So, because of that, row location is equal to 0 has been assigned, we have to break. So, that way we will be making up with rows equal to FD, that means the second row, ground the row 1. Now, you read the column, check for mask with 0F, so that the lower bits are there. You check whether it is 0F. If it is 0F, then nothing is pressed over there. If it is not equal to 0F, then something is pressed. So, we will be finding up rows equal to 1. So, if I have assigned row, what is the row, whether it is 1 or 0, then I have to break and have to come out. If both the things are failed, then I will come for the next row, so that FB is given as FB, row is equal to FB, that means the second row is grounded, and I have read the column. If it is not equal to 0F, then row is identified as 2. So, that way either one of the row, either 3 or 2 or 1 or 0 is pressed, then I will be identifying any one of the thing, so that I will come out with break in that particular respective routines. So, now I will be looking up that I have to identify which is the key is pressed. So, if COL LOC, that means column we have identified, which is equal to 0E, if already we have identified what is that particular location. So, if I am expecting that if COL LOC is equal to 0E, then SERTX keypad of row location. So, that means the row location is identified already, it has been assigned either 0 or 1 or 2 or 3. So, now keypad of 0 and 0, that means it is in the 0th row. So, 0 0 is identified. So, now 0th row, the different columns, the different rows and the 0th column is identified. So, that we will be checking up. If it is on the second row, then SERTX keypad of row location, comma 2 is there. So, second column and row location. So, that way we will be identifying any one of the key with your rows and columns identification. We will be calling this particular one, where the SERTX is saying that we have already stored the keypad having 4 cross 4 matrix. So, with that we will be identifying which is the key pressed. So, that particular value is sent for serial communication. So, by calling SCRTX. So, SCRTX where SBUF is equal to X, that is the value we have sent over there, and while TI is equal to 0, we will be waiting for TI is equal to 0. So, till then TI is equal to 0, we have to wait. When TI is equal to 1, so the completely the whole data is sent to LCD, so that it has been displayed in the LCD. So, that way we will be doing it. Now, we have sent serially to outside world. Now, unsigned integer x comma y, this is for making the delay, where for 1 millisecond I need to make it 1275. For how many values we wanted to have it, that many times this nested loop is called, so that delay is maintained. So, now remember that I have just sent the data serially. If we need, the LCD also has to be connected, that particular code has to be called to display with your LCD. So, this particular code demonstrates a 4 cross 4 keypad, how we will be reading which is the key pressed through this particular embedded C code. So, the next is the external RAM. How we need to know how to connect an external RAM and how to read the data from the external devices. So, in this, remember that this EA is external access and ALE is used and PSEN is used to identify that which are the pins has to be connected either 0 or 1, which says that whether it is a program code is taken from external device, the data whether it is available in the on chip or in the off chip. So, all those things is communicated through this particular 3 pins. So, now you just see that some of the ports are multiplexed, so that we will be in a position to access more number of addresses. So, you just see P0 is multiplexed, so that it sent through a D device, so that the ALE is equal to, based on ALE is 1 in the sense this sends the address to this side. If it is equal to 0, this will not send the data. So, data read and it is coming over here, and the read bar, write bar is taken from P3.7 and 3.6, it has been given over there. So, if I am looking at an external data RAM which has been connected through this kind of setup, P0 is connected over there, P2 is connected over there as data, as address lines, these two are address lines, and data line is connected to P0. So, this read and write bar is connected for WE and OE for selection as well as writing. And if it is a program, then this PSEN is connected to OE bar, so that chip selection is enabled. So, this is an example code for reading a data from your external devices. Remember that when you wanted to, this is an example program, write a C program to store ASCII letters A to E in external RAM location, addresses starting from 0, and send the same data from the external RAM to P1, 1 byte at a time. So, when you are accessing an external memory, we need to include absacc.h. This header file has to be included definitely to make it X byte. That means the byte is taken externally, that has been taken from X byte file. So, accessing external memory can be possible only by including this particular header file has to be included. So, along with your reg51.h. Now, you just see that unsigned character X. So, A is assigned to X byte of 0. That means, this 0 says that address of X byte. So, ASCII letter A to external RAM location 0. So, X byte of 1 is B, X byte of 2 is C, X byte of 3 is D, X byte of 4 is E. So, ABCD is assigned to from starting location 0 to 4 of external device, external memory. External memory is addressed through X byte, and the address is given through this kind of subscripts. So, now we just see that for X is ranging from 0 to 5, X plus plus, this is P1 is equal to X byte of X. So, first time X byte of 0 is sent to P1, next time 1 is sent to P1, and next time that X byte of 3 is sent to P1. So, that way whatever be the thing which we have written in your external RAM memory has been sent to port 1 through this particular code. So, this is actually to external RAM uses 8051 data space to store the lookup table from the DAC data and write a C code to 30 bytes of table data and send it to P1. So, when you wanted to have it, you need to include absacc.h as the header file. Now, you just see that character count, because it is within 255, so declared as character variable. Count is ranging from 0 to 30, count plus plus x byte of 0x100 plus count. So, starting from 100h, it increments based on the count, and x byte of that particular value is sent to P1. So, it is a very simple task when you are looking at an external device. Only the connection is very important, but you can refer it through the word x byte. Only thing is you have to include the library properly. So, when you are looking at this particular model, we have discussed about the basics of interfacing 8051 to external devices, as well as we will be looking at how to interface an external memory to 8051, and we have demonstrated how to handle these external devices and external memory through embedded C code with respect to 8051. So, you can refer this through this particular book. Thank you.